Alright, so here's our Rotary transformer version 3. This time we're just using a small universal motor out of a vacuum cleaner, rated at 850 watts on 240 volts AC. So just a quick rundown on what's going on here. Both the coils on the stator have been disconnected. This motor is running purely by attraction of the rotor when it fires up towards the laminated cores of the stator. One coil is being used for our generator, the other coil is being used as our bucking coil in the situation. We'll get into that later on, or we may not. And interesting things happen when I place a load on, but we're going to do it unloaded. This is just a quick version demo for the forums. To be straight out and honest, this is being researched in another place, out of the public eye at the moment, and you'll see why shortly. Okay, so just our basic circuit and smoothing cap 3300 UF to try and smooth the pulses out. It's got rid of most of them, so our meter will be fairly accurate. That's just a 12 volt globe, automotive globe, tail light, and that's pretty much it for the circuit. So this meter here, you'll see it's coming off our positive side of our cap, going through into our globe and then out of the globe through the switch, and this meter here will be reading the current from our 12 volt battery supply there. That is getting sent to the motor, so it goes through the meter, and then this peg is just loose. I will hook it up to the positive side of the motor and away it will go. So we'll start it up and we'll check out the amps, and we're going to use our scope to look at the voltage both across the motor and across our globe. So our red channel is across the motor, channel A, and channel B, the blue channel, is measuring the voltage across our globe. You will see the slight ripple. The cap's not quite big enough, but good enough to do the job, and I'm sure this meter will be having no trouble reading it, because I know it will be showing us about the same current that globe takes to draw on a pure DC voltage or a pure DC current supply. So I know that meter is very correct. Alright, so let's start it up, and it is a bit noisy, so bear with me. Okay, so we have about 13.4 volts across the motor, which is standard for a 12 volt battery. That battery bank there is for my UPS, so that battery is getting charged as it is running. And the current, about 2.07 amps. So 2.07 amps at our 13.4 volts is what's running the motor, and of course nothing through the globe yet. So now we're going to switch the globe on. You will hear the motor bog down. This switch does the globe, and it also brings our shorting circuit into play, but it is very different with the load on it, and we'll leave that for another video. So now our motor drawing 736 odd milliamps, still at our rated voltage, and this is across our globe. You can see we have about 10.6 volts. 11 volt max, so 10.6 volts RMS because it's got a slight ripple in it, and the current is 1.645 amps. So I can turn the globe off, you can watch what happens. So now that is showing you the complete opposite to what you would normally get when you slow one of these universal motors down while it's on the same voltage, you normally draw more current. So I'll switch that back off. That red lead's a bit of a pain in the arse, too. And I'll load the motor with my finger without burning myself. So you can see when the motor bogs down, we draw more current. When we switch the light on, the motor bogs down and we draw less current. That's because something is changing in the motor, and like I said, I'm not going to get into that. It has to do with the way these coils are configured now. But that is our current draw for our motor. The voltage across the motor, which is the yellow trace, the voltage across the globe, which is the blue trace, and the current through the globe. As you can see, that is the current through the globe. So there you go. Besides that getting a bit warm without the fan on it, this fan actually diverts some of the air down through the motor. So it gets a bit hot without it, even at that low power consumption. But anyway, good enough for a test run. Still a bit more work to do. I think I want to go down in wire size on the coils to get the voltage a little higher and the current a little lower, so I can get up into driving 240 volt outputs instead of 12 volt outputs. But we'll see how we go. I do have a bigger universal motor. I may use that instead of this one and just keep this one for the experimenting we're doing here. So now there's a problem with looping it, because if I loop it, then I can't get this coil shorting effect to take place, which is going to be a headache. So it's going to have to power from the output back into a battery, and then the battery is going to have to run the load, which is much of a loop, and we don't like using batteries because we know what tricks they can play. So yeah, but anyway, that's what it is. That's what it's doing at the moment. And we'll let you know how it all pans out. Thanks for watching, guys.